In this lesson, we discuss common cyber defense against buffer overflow. We analyze the misconceptions of using string ncopy and or string ncat to be safe. We also show how to use execute stack protection feature provided by some of the operating system to block stack code execution. We introduce stack guard runtime stack integrity check techniques. And we also show the more advanced address space layout randomization, ASLR, which is currently being used by major operating systems, and the very interesting instruction set randomization defense technique proposed by Columbia University, a researcher at Columbia University. HTTP Apache software some long time ago published buffer overflow patch for their HTTP passport utility version 1.3, and they announced by replacing their vulnerable code, which has string copy record with record and user parameter, and then followed by string cat record with semicolon, followed by copy to the record appended with current password, CPW. So user and CPW are from the input. Because the string copy overflow the record variable, they try to patch it with a string ncopy with two parameters, user and max string length -1 constant, by limiting the number of bytes that will be copied from user to the record variable within the system. And then using the string cat to append the semicolon, because most of the password file is contain the field user followed by colon followed by the password. And then the last statement was replaced with a string ncat to the record variable with a current password, but limited the length to max string length -1. After a while, people start to say, "Oh, this won't help, because can you see why this patch will not work?" And the buffer overflow can still happen by hacker to this patch code. It turned out the records of the same, if the record is of the same size declared as max string length, the hacker can actually provide user and current password with exact the same length. And when the first user data was copied, we already used up all the length of the record buffer, right? And so the colon will could override the stack frame pointer. The remaining current password that is brought in by the hacker could start to override the return program counter. So the patch doesn't work. The better solution is to test the combined size of the user and CPW, current password, before we even attempt to copy the data into the record local variable. Okay. You can turn off stack execution by installing a utility called exec stack, execute stack. Here we show you can using the execute stack with minus query options. With that command, the current system will set to allowed stack execution for a certain program. It will return what kind of current setting. If return is minus sign, it means the current system is set to not allow stack execution. in that kind of setting, the system will protect and not allow the stack execution when any hacker try to inject the buffer overflow attack. It will produce segmentation fault. And here we show an example of TSC program that contain buffer overflow. If this is executed when the system with that minus sign set up for the execution flag, then it will produce a segmentation fault. The other possible return from the minus query result is X, which means allow execution, allow stack execution. We, as you can see here, we get a shell in this case. So the code we have execute minus Q when we with a program name TSSC will return minus followed by the program name, which basically this program is set to not allowed stack execution. And then as you can see here, we follow up with ./TSTSC. It produce the system give you a warning. You produce a segmentation fault. And then we set with the minor S to set this TSTSC to allow stack execution. And when we execute, it turns out with a response coming back $3.00. And that prompt basically showing you that we are now giving a different, completely different shell produced by the shell code in the TSC. One technique to discover the buffer overflow is using static source code scanning. Tool like HP45 can detect most buffer overflow vulnerability by reporting the dangerous function code. They scan through the program and identify those dangerous function codes, such as string copy, string cat, string f, string n copy, string n cat. And then also point out the input variable or input data that will be passed along to use as a parameter to this set of function code. Runtime stack integrity checking. Here we present a buffer overflow detection mechanism deployed by state guard systems. It is called runtime stack integrity check technique. This security defense mechanism is very generic and can be used in other settings, other security system area, such as in military operation. An additional data pattern called canaries, which is a very unique kind of pattern, can be inserted in the stack frame to write below the stack frame pointer to protect the stack frame pointer or the key data area. And we can verify whether that pattern got changed. We verify its integrity when the function returns. And here is the canaries used as in how the typical this kind of bird is used in the mine. And when there's a gas, those birds die and the miner will run out of the mine. Okay, there are two kinds of canary values that are proposed, right? One is random canary. We choose a random strings at the program startup, and because random is more difficult for hacker to guess every time, they need to either have access to the system using the debug to figure out how this random value is set. Different program will have different getting to different random value at different time. Okay. We insert the canary string into every stack frame, and we then verify the canary before returning from the function. There's a return function execution sequence. To corrupt the random canary attacker must learn the current random string, which is harder for them to do. Unless before in the function call, they can actually scan, read out those stack frame area, and then try to leverage on that. The other type of canary pattern is called terminator canary. And because we know if we set the canary pattern to be 0, and new line, 9 feet, or end of 5, any of those characters, then when the data was copied from the hacker to overflow the local buffer, the 0 will be fed into the have to be read in, and the string copy will stop right there, and therefore the attack will be stopped during the string copy, and cannot be overwrite any of the stack frame content. However, the hackers still can attack the return execution kind of sequence and try to write a different kind of pattern in that position. That's called stack smashing technique. And it can use that to override the return from the calling function sequence. Here we talk about address space layout randomization, shortened for ASLR. It randomly arranges the address space position for the key data areas such as stack or heap or library. And instead of allocate them into those memory, virtual memory MAC we showed you before, it was randomly allocated. And it makes it difficult for hacker to guess, right? Any of those stack area or the heap area where they are actually located. Without knowing their actual location, whatever the code they prepare will not be jumped to and execute. And this is first implemented by a group called Linux PAX, July 2001. And after that, it has been used widely by and implemented widely by major operating systems, including iOS and Android. Recently, October 2016, Dmitry Ivyaskin et al. Actually at Sunny Buffalo SUNY University presented a side channel attack on the branch target buffer. They can guess what is the offset. They can derive the kernel and user level ASLR offset, and therefore they can jump and modify their code. Here we talk about instruction set randomization technique, shortened for ISR. Gaurek Casey, who is currently in Google, when he studied at Columbia University, carry out a research and present this instruction set randomization technique as a mechanism to counter the code injection attack in the most prestigious ACM CCS, Computer Communications Security Conference 2003. They applied the cutoff principle by creating process-specific randomization instruction set, changing the instruction OP code to a different code for each instruction. And by doing that, whoever prepared by the hackers, their instruction will not be interpreted correctly, right? Instead of load, which is maybe code, OP code 07, and in their ISR instruction set will be 77. And therefore, the execution will be not correct, or the code is out of range of the OP code in the new instruction set and will causing the code error. But even though this technique is very powerful and can deal with many different kind of attacks, but it has significant performance penalty. And in the paper, it indicate it could be one order of magnitude with 10 times or several order of magnitude in terms of overhead. So because every instruction needs to be interpreted and executed. But they do mention they have an implementation modified interpreter, just interpreter type of protection, ISR protection mechanism, which is more efficient.